All right. A new flu virus is introduced when a stranger visits an isolated village with 8,000 people. Every infected person infects 2 more each day. Write an exponential function to model the number of uninfected people. Determine how many people remain uninfected after 1 week. After how many days will the entire population be infected? So, let's do some math. Let's just look. So if I get one person infected the first day, he in turn is going to infect 2 more. So how many are we going to have total at the end of for the second day? Okay. Day 1, we had 1. He infected 2 for a total of 3. So at the beginning of day 2, now we have 3 people. They all infect 2 each, so that's 6. So we have a total of 9. So at the start of day 3, we have 9 people who infect twice as many, so 18. So we have a total of 27. So the 4th day, 27, so on and so forth. So what do you notice we're incrementing here? By a factor of 3. All right, so we know the growth of this is 3x. X represents days. So after the first day, we had 3 people infected. After the second day, 3 squared, we had 9. All right, so there's our growth rate of our infection. Well, how many people do we have on our island? Well, we have 8,000. Okay, so 8,000 people are going to get infected eventually. So 8,000 minus whoever is infected, because that's going to model the uninfected. But don't forget we had some Yahoo come on the island, so we really have a population of 8,001. So for part A, by inspection, we know the number of uninfected people is going to be 8,001 minus 3 to the x power. So B, write an exponential function or determine how many people remain uninfected after 1 week. So y is going to equal 8,001 minus 3 to the 7th power. Okay, we'll just plug that into our calculator once I get it set up for us. Okay, so here we go. So we can say 8,001 minus 3 to the 7th power. We're going to have 5,814 people not infected. So the next question, how many days until the entire population will be infected? Okay. Well, let's try 10 days. So really, we just got to set 3 to the x power equals 8,001. So this is how many days? So all we got to do is just get our calculator out and go, what is 3 to the 8th power? Okay, it's more than that. 3 to the 9th power. Whoa. So we know somewhere between the 8th and 9th day. So part C is by the 9th day, the entire island's infected. Okay, so kind of look that over, see if that makes sense how we set it up. Okay, moving on. Okay, 6 through 13. So 6, write each equation in logarithmic form. So 6 would be log base of 7 of 49 equals 2. 7 would be log base 10 of 1,000 equals 3. Number 8, log base 5 of 625 equals 4. Number 9, log of 1/10 equals -1. Remember, I don't have to put the base because the base is assumed 10. Number 10, log base 8 of 64 is 2. Number 11, log base of 1/2, or log base 1/2 of 4 is -2. Number 12, log base of 1/3, 1/27 is 3. 13, log of 0.01 is -2. Okay, 15 through 23, let's look. 15, okay, log base 4 of 2 equals x, so equals x, so 4 to the x power equals 2. So 2 to the 2x power equals 2 to the first, so x equals 1/2. Okay, 17. Log base 4 of 8 equals x, so 4 to the x equals 8. Well, 4 can be prime factored to a base of 2, so 2x equals 2 cubed. Okay, so x is going to equal 3/2. Okay, 19. Log base 49 of 7 equals x, so 49 to the x power equals 7, so 7 to x equals 7 to the first, so 2x equals 1, so x equals 1/2. Okay, 21. How far do we have to go on this? 23. So 21. Log base 3 of 9 equals x, so 3 to the x power equals 9. Well, 9 is 3 squared, so 3x equals 3 squared, so x equals 2. Okay, 23. Log base of half, log base half of half, so it's 1. Anytime the numbers are the same, it's 1. Okay, number 35. Graph each logarithmic function. So we're going to drop our handy dandy chart down here. So first, let's set this in exponential form. So 4 to the y power equals x. So we're going to plug in values for y and solve for x. So -2, -1, 0, 1, and 2. So 4 to the -2 power would be 1 over 16. 4 over the -1 power would just be 1 over 4. 4 to the 0 power would be 1. 4 to the first power would be 4. 4 squared would be 16. There we go. Plenty of points. So when y is -2, x is 1/16. When y is -1, x is 1/4. When y is 0, x is 1. When y is 1, x is 4. 1, 2, 3, 4. When y is 2, x is 16. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is good enough for us to sketch our curve. There we go. Easy enough. Next one. Graph log y equals log base 3 of x minus 5 plus 3. Okay. This one's not a big deal. It's fairly simple. Okay. So the parent function is really y equals the log base 3 of x. And we're going to translate in 5 units because our h value is going to be 8 to the right. So 5 units to the right and 3 units up. So let's set this in exponential form. 3 to the y power equals x. So let's set our x and y's up like we have been. And let's keep them fairly simple. -3, -2, -1, 0, 1, 2, and 3. Our x value is going to be 1 over 27, 1 over 9, 1 over 3, 0, sorry, not 0, 1, 3, 9, and 27. So those are easy to plot with the parent function. So when y is -3, x is right there. When y is -2, it's still really close to that. When y is -1, it's a little bit farther. When y is 0, x is 1. When y is 1, x is 3. 1, 2, 3. Y is 2, x is 9. 4, 5, 6, 7, 8, 9. Another 9. 3, 4, 5, 6, 7, 8. So there's 27. So here's our parent function. Okay, but now we got to move it up 3 and to the right 5. So up 3, 1, 2, 3 over 5. 1, 2, 3, 4, 5. So up 3 over 5, up 3 over 5, up 3 over 5, up 3, 1, 2, 3 over 5, 1, 2, 3, 4, 5. Alright. And there's our points. We translated up 3 to the right 5. Easy enough? Okay, write the equation in exponential form. So log base 2 of 128 equals 7. So 2 to the 7th power equals 128. Okay. 54 would be 10 to the -4 power equals 0.0001. Next one would be 7 to the 5th power equals 16,807. Okay, 65 and 67. Find the inverse. So let's first set 65 up. Y equals log base 10 of x. So we can say 10 to the y power equals x. So to find the inverse, we just got to flip it. So 10 to the x equals y. Alright, 67. Y equals log base 10 of x plus 1. So this function would be 10 to the y power equals x plus 1. So we got to flip inverse, flip it. So it's 10 to the x equals y plus 1. So we got to subtract 1. So 10 to the x minus 1 equals y. So that's our inverse. Alright. So 20. How do we graph this? Well, the parent function is 2 times 2 to the x power. We're going to translate it left 1 and up 3. So which one gives me left 1 and up 3? So the answer is A. Okay, 25. Evaluate. This is nothing more than calculator work, so let's get this going. E to the first, so this is easy. Just plug it in our calculator. So that one's 2.7182, so the answer for that one's D. Next one's e to the -1. Make sure you use the negative sign. .3679 e to the 5th. 148.4132 e to the 1/2. Again, easy calculator work.